So everything's frozen, and this is just warm water. And just thawing this out. That's all it is. So that's what's in there, is one of these. It's exactly 1 ounce. So this came out of an electric motor and transformers and everything, you know. This came out of a Siemens motor. I'm not sure what the motor come out of. That's what I've been working on while everything's froze. Working at a couple 100 pounds of copper. Working on transformers and some motors. I probably won't take apart those big motors. There's some transformers need to get cut apart. Can't take them apart by hand. And just taking apart stuff. It's all full of transformers. Taking apart some scrap metal. This wire came out of a Siemens motor. There's two of them. So it could be, you know, brass, but it's hard to say. So the blue sediment may be silver with a gold plate insulation. So if it's a gold insulation, it's like 1 carat gold over silver, maybe. Because you're not going to put a cast wire. It's going to be 24 karat, whatever this is insulated over. So I put this one in a pipe. Pipes around here somewhere. Put it in a pipe, packed it up in a Reese's peanut butter cup. They're all 1 ounce each. There's one in here. The first run with this, that's the exact same amount, nearly the exact same amount as what came off the contacts. See the contacts are wearing down, making a blue sediment, and it's for 3 or 4 runs off the contacts. That's all the sediment that came off of it. In grams, a couple grams. You see the copper, it crumbled, and it's a steel plate or a solid, more stronger copper plate. But you see it's size reduction. See, it's definitely shrunk. And that crumbled. The copper crumbled, and it was a solid that deposited. It's in this glass right here, frozen. This one's brand new. And these two we've seen in the previous videos. I've run these two. So that's what this is. And this sediment has come off it as well, off one of those breaker contacts. That was on a fresh hydrogen peroxide, unspent hydrogen peroxide. So all this sediment and that one, that come off the contacts. And one of these balls, the first run, well, 2 runs have produced this sediment. It's frozen, and standing up like it is, it's frozen. There's really not very much. You see, the same amount that's in that one is nearly the same as what's in that one. But after the first run of this, it's lost color, setting it next to these two. So it's losing color and becoming brittle. So it's not easy just trying to rip these wires, spread them, break them in half. You could get like a razor cut if you tried to. But they're just breaking off. There's some pieces down in the bottom. But see how it goes. Completely frozen. And just let it get some activity in there or something. It unfreezes. It just looks wider because there's water in between the glasses. Makes it look expanded. So these are the other sediments that are from different things. See, this is a flip phone. This was a flip phone. These two here. So this run right here on the flip phone, I ran for like 3 days, where this run was only 1 day. about 12 hours or less. And this one is first run off a Intel processing chip. And you see in the other videos, the Intel and Pentium chip. This came off the Intel chip before adding it with the Pentium chip because it was produced in the same sediment. So that's the first run. This is deposits, or it's from the pins and connectors. It's what's left off the big batch. Last run off that. This produced somewhere around 35 ounces of sediment. And there's I don't know how many ounces that weighs. Figure it out later. This is a sediment off the 3 PCBs. Previous video. Drilled it out. So I put it on the frying pan and dried it out. It'd be a darker color. But that was from 2 or 3 runs off the 3 PCBs and all the sediment added together. And this one is the first run of 10 days of running HP PCB not depopulated. Everything is still on there. You see in the previous video, HP. And this is from the fingerboards. Something different. So that's what's left of after running flip phones. This is in here as a Apple, maybe a couple Apple phones. It's almost hardly even recognizable. There's some IC chips left in there. Here's a flip phone. What's left of it. That's all that's left of it. Throw away the garbage. Take out the steel and plastic. Where it went. You're only using hydrogen peroxide. I'm not using acids. This is part of the flip phone. And that is the laptop, Toshiba laptop. Still got to take off the chips, but I've removed all IC chips. I don't have any boards left with IC chips. I depopulated everything that was left. These are visible gold boards, and this will be the next video. Beyond Rocket Science Part 10 maybe. I want to put it in a fish tank, stand it up in a fish tank, and see what it looks like. It's a cheap board. There is some gold, visible gold on the board. So the last, the HP, I left this on here. On the HP, you see in the video, the brown sediment all accumulated on this. And there isn't any decay on it. Right here. This is the from the HP. You see in the previous video the all the brown sediment was on here. That's baking soda. So the next run, I'm just gonna leave that on there probably, but just take that and just move it off to the side a little bit and lock it back down. See, it's a cheap board because there's no gold on that battery connector. There's a little bit heavier here because they get out of date so quick. They're using less gold. Simple common sense. So these are the other projects. This one was, from the contacts. So this was LED sediment. This is LED sediment. It's LED sediment. See, it's just dehydrating. It's frozen. It's just losing its water. So it's through your LED sediment. And this one. That's the LEDs. Right here. Gonna get run again. So there's the amount of IC chips. All four-legged ones. Nearly half Mountain Dew bottle, but you see in my previous videos 6 to 8 months ago, processing IC chips, a couple Mountain Dew bottlefuls, and this is I put all the micro components, MLCCs, in here with the three-legged transistors, MOSFETs. This is my last transistors and MOSFETs that I processed. They were chemically processed. This is just hydrochloric and AP. That's copper. Nothing but copper. All MOSFETs. So this is a coin. Heat sinks, coin, and flip phone. So the heat sinks. That's a sediment from the heat. From these 2 heat sinks are running on to lime, nickel, whatever. Just a short test. So this is some plugins, connectors off the boards I've been depopulating, and that's just a little bit of pins and connectors. It's probably silver. There, that comes out the boards. Yeah, that's what's it's part of the deposits off the PCBs. But this is what's in here. So it took 2 months to run these. It was 80 plus ounces or so of all pins and connectors. All visible gold pins and connectors. Highly concentrated. And there's like 35 ounces of sediment that I've taken off these pins. But that's all I've been able to accumulate. That just, fall off the boards and are depopulating. I'm leaving the pins on the boards because I have to depopulate, and no more, because you'll see the boards. It takes a long time to get those pins off there after you get them off the boards, but just leave them on the boards. Keep running them, just hitting them with electric, and all the sediment comes off. So if this is gold insulation over silver or something, but if it is, it's a very low carat. If you took the insulation and measured it, if you took a mile of insulation off this wire right here, you'd need a mile of it to maybe get a gram. That's how light of a covering that it has over it. It's just like an epoxy. It dries real quick, but there's not much there. It's what's underneath. And the blue is what's underneath. Once that thaws out, it'll start having some activity, and water's still warm. Use some more hot water. Another shot might. take a break.